Okay, so we're going to move on to pattern number 2 now. So we've talked about what to do when you've got a robustness problem. But the thing is, what causes these robustness problems? What breaks logic that works under correct input and output? What breaks perfectly good logic? We've already heard this. Yes, please?
Unexpected, like null characters.
Unexpected characters, null characters. That's a good one. That's a very good one. It's worth saying here, then, that PHP, at least, because its strings are binary safe, it doesn't use the null character like C does to indicate the end of a string buffer. So memory overflows from your PHP code are harder. Not impossible. If you're working with a binary protocol where you're having to do it all yourself, you can screw up. But it's very, very hard to do. It's one of the advantages of using a higher level language like PHP. I mean, in the C days, I'd say most of our robustness work was focused on dealing with that null character. But we've talked about bad inputs breaking logic. So here's a little example. And it's deliberately noddy, but sales tax, VAT, something we all have to do if we do e-commerce. You have to calculate how much tax has got to be added. And of course, you've actually got to show that value as well to the customer. You can't just charge them for it without telling them that. I can't remember which law or trading regulation that's against, but you're not allowed to do it. You have to be able to show them it, so you've got to calculate it. And if you give them, so this is happy path. You give it the right input. Hopefully you can all see at the bottom, output's 20, which is the right value. 100 units in, 20% tax, so they pay 20%, which is 20. Okay? Everyone okay with that? So what happens if we change the tax rate and throw something else in? So null's been coming up. I was expecting PHP to crash when I was doing this presentation. It doesn't, of course. I forgot. What it does is null gets converted to 0 if you're doing maths. So what happens is no sales tax. Your customer's very happy, but you've got an awkward conversation with the VAT man once a quarter. But this is not a correctness bug. Your algorithm, there's nothing wrong with your algorithm. If it's got the right inputs, it produces the right tax value. The problem is we've thrown it something it's not designed to cope with, which is null. And PHP hides that from us by converting it to 0. So you don't necessarily know whether or not you've got a bug here. Now, null, you may, right, so why could null end up in here? Tax rates do change. I'm told they come down. They only ever seem to go up these days. So what people normally do in a e-commerce system is they have a database table which says valid from, valid to, tax rate. So you can prep all your production systems in advance, and then when the clock flips over to the day, the new tax rate is used instead. That's what a lot of e-commerce systems do. Remember our SQL from earlier on? If that SQL had failed, you could have easily ended up with null being propagated through to your calculate sales tax function. That could easily happen if you've got robustness problems elsewhere in your system. Those values can propagate and then hit other code that's not robust. But where's your bug? How do you find that? Because all you're doing, if you're debugging this, is you're seeing an invoice with sales tax of 0. You look in your database, right dates, right value, what's going on? You're starting to spend a lot of time debugging code, and you don't know where to start. And one thing I've noticed is a lot of people these days aren't trained how to debug and maintain code. I'm old enough to have worked in the pre-web industry. We all debugged and maintained code. That's all we did. You had to have 10 years plus seniority to write new code. Hardly anyone got to write new code unless you were lucky enough to be working on a Unix system. The rest of us didn't. Yeah, and it was dead man's shoes as well. You had to do your 10 years. Didn't matter how good you were, they didn't care. That's how this industry used to be. The web's completely changed it. Now, most people spend most of their time creating rather than just debugging. I mean, they're debugging stuff they've created because they haven't managed to ship it yet. But that's a different problem, I would argue. But you buy a lot of programming books today, and I'm not going to name any names because it's not fair on them because they're not here to defend themselves. And you'll struggle to find chapters explaining methods of how to debug code. When was the last time you read a programming book published in the last 10 years, never mind 5 years, that told you how to do this? Has anyone?
I've made one comment in my office of 30 people. I'm the only person first who runs the debugger.
Okay. So the other 29, how are they debugging and maintaining code, or are they just hoping you'll do it for them?
Well,
I've been on projects where developers have expected others to do the work for them and not done it themselves. So it does happen.
I think they're happy if something doesn't appear to be broken. They're happy to assume it's not broken.
Yeah. And that's partly because systems are very complicated these days, and there's a lot of time pressures as well. It's not. When I was younger, I used to get frustrated and think, especially because I'm from a different programming world, you could argue. And I used to get frustrated with people who didn't do these things and paid no attention to them. And it took me a long time to realise it's simply because most people are like the duck underwater, paddling furiously just to stay still, just trying to keep up with deadlines and everything else. There's so much time pressure on us these days. I mean, we turn software around in nothing compared to systems of old. It used to take 3-5 years to build a system in the old days. Government projects, you could argue it still does. But for the rest of us, we don't have 5 years of budget, or even 3 years of budget. In the startup world, sometimes you're living month to month, or quarter to quarter, and you've got to ship, and you've got to bring money in. You have to hit these deadlines. It's a different world. Anyway, coming back to our example. What happens if we throw something weird in? What happens if tax rate somehow has ended up being an array? And we will discuss how that could happen later. What happens then? We get a fatal error. Now, I believe when I was testing this, I believe I ran this on PHP 5. And anyone who's seen a fatal error on PHP 5 knows that's it. PHP's called die for you. It's game over. You can't recover. There's nothing you can do. Your system's torched. And depending on the state of your system, when it's torched, that could be quite a mess. PHP 7's a little better, thankfully. But the point I'm trying to make here, we're a lot of tangents, admittedly. Type mismatches break good logic, because the logic's written to expect certain types, and then different types come in, and that's when your problems start. So we've already heard the answer to this, but the standard solution is check incoming data before you use it. Input validation. We've heard that with forms. We've heard that mentioned before about checking inputs to functions. PHP 7 and type hinting. PHP 7 has made some very nice improvements to help with this. In PHP 5 and before, you could... Well, first of all, apologies. Does everyone know what type hinting is? Yep. OK. So PHP 7's extended that, because before you could only use object types. Now, you can use scalar types. So what we can do now is we can say total's got to be an int. If you're dealing with money, never use floats. Never, ever use floats. The tax rate's got to be a float. So now if we pass our array in by mistake, we now get a type error. It's like an exception in that you can catch it, but it's not inherited from exception, so your catch exception block won't catch it. You've got to do catch error block to catch these. And this is PHP 7 starting to make things more robust. In PHP 5, you had a problem, that was it. Mess everywhere. PHP 7, you're starting to be able to recapture and recover from some situations. How many of you are still using PHP 5? OK. And how many of you have managed to move to PHP 7? So almost half-half. People have talked a lot about the performance of PHP 7, and by God, it's a lot faster. It's fantastic. And if you write something you may not have heard, if you write small functions in PHP 7, they execute so much faster. It used to be in PHP 5, you had to avoid lots of function calls because the overhead of a function call was really, really painful. In PHP 7, because what they've done with PHP 7, they've made it more friendly for how the CPU caches. It's level 1, level 2, and level 3 cache. They've made it more friendly for that with Intel's help. As a result, small, tight code now executes the same way as it would with C. It's a lot better than it used to be, because you haven't got these data structures and knackering your CPU cache lines and stalling everything as much as before. Huge improvement. And you've got type hinting. Now, a lot of people, those of you who use composer packages may have seen this very sudden march to PHP 7.0 and then PHP 7.1, and they're all chomping at the bit, ready to go to PHP 7.2 the moment it's stable. And they're aggressively dropping support for older versions of PHP, especially PHP 5. And one of the justifications given for this is that type hinting makes your code safe. No, it doesn't. It helps, but it's not perfect. One of the problems with it is you can't, sometimes it's legitimate for you to accept different types at the same time for a parameter, because at the end of the day, we're writing dynamic code. We're not writing Java, we're not writing C, we're writing dynamic code, and we want to use PHP's power, so we write less code, and to do that, it means we've got to be flexible on our data types. You can't model that in type hinting at all. But the main problem with type hinting is it only tells you if it's the right type. It doesn't tell you what's inside the damn thing. Negative sales tax, you're giving them money. And you've still got the awkward conversation with the tax man every quarter, yep. It doesn't validate your data. It just says you can use this value and your code's definitely not going to crash. It doesn't mean that your code's going to do the right thing. And here's another example. Something a lot of us do is we write mini parsers to extract values out of strings, and we often use regexes for that. You're familiar with regular expressions, even if you don't use them yourselves. So here's a very simple example. We've got a string to pull out an ID from. We want to pull out the ID of 100 out of this string. And here's the regular expression I'm going to pass in. That regular expression is wrong. It's wrong syntax. It won't work. And when we try to run it, we get a PHP outputs a warning and then returns null. So how many of you notice all the warnings that your PHP code generates? Do you even know where to look for them? Yeah? A lot of people don't, you'll find. I've seen projects go to production, hundreds of warnings every time it executes, because nobody knew about them, no one knew to look for them. All they saw was the fact that they were getting data out. The fact they're getting the wrong data is something else they should have picked up on. That's a different problem. They weren't aware of the fact they had a bug in their code because PHP wasn't forcing them to be aware of it. So what would you do about it? What would you do about that regex being broken? How would you catch that? There is a way to validate a regular expression, yep. So is that what you would do?
I think validate it first. And then
you'd validate it first. Okay.
Yeah.
Anybody else?
Something.
Sorry?
Does it not return something?
It,
Tells you if it was successful.
well, then it's returning null. It's not pulling out the number. It's returning null. But the problem is you don't know whether or not there's definitely an ID in that string. That's why you're using the regex to see if there is one in there. So you can't tell the difference between an ID that's broken, an input where the ID is not present, and the fact that the regex isn't working correctly, if you're ignoring warnings. Okay. Anybody else? Right. Yeah, right. So I'm going to introduce two new ideas. I call them checks and requirements, and they're interlinked. They're a way of doing input validation, a little coding pattern you can use, which makes them very easy to reuse and not a lot of effort to use. So I'll introduce a check first. So what I've done is I've written a PCRC regex validator, exactly as you said. So first thing I do is before I use the regex is make sure it's valid. And if not, I throw an exception. Which means when I get down to line 11, I know that the regex will run. So I've dealt with that robustness issue there. It's going to catch the problem of me passing in garbage because the exception will be thrown. Okay? Very straightforward. And it's often its own little class, so I can use it all over the place. It's nice and small, I can reuse it everywhere and everywhere. Seem all right so far? Very simple validation. The code behind it's really noddy. All it does is actually run the regex with all the warnings in the world switched on, temporarily switches on, overrides your own settings, switches on all the warnings and looks for them. And if there are any, it says, okay, that regex isn't safe to use. So unfortunately, it's an expensive check, but you can do it. There's normally a way. Now, that's 3 lines of code. That doesn't seem too onerous, does it? Be better if it was 1, though. Do you all agree? Yep. And that's where a requirement comes in. So I've taken that check and that code that tests the output of it and throws the exception, and I've wrapped that in something else what I call require valid regex. So that's all I do. I apply my validator to the regex, and it throws the exception so I don't have to. So I know if I get past this line here, line 6, if I get down to line 8, line 9, line 9, I know that the regex is good. I don't have to check a return value. I've eliminated that from my API design. But internally, I've got that check separated from throwing the exception, so I've got that flexibility in the future, so I don't have to repeat code. And that's a requirement. And of course, depending on how many inputs you've got and the complexity of your system, you just stack them up as many as you need. And that sorts your problems out. So that's how you can do input validation very, very simply across your code. Everyone are happy with that? Any questions? Nope.
I've been trying to do it a different way to that.
Okay.
In that rather than passing a string in, I pass a class in.
Okay.
So the match token would actually be new valid regex and then that number, and then the validation is done in that class before it even enters it. And then it would fail to even get in there. And wouldn't I expect string regex, or I expect valid regex.
Right. Okay. That's another way to do it. The reason I don't use that is I tend to build larger systems where performance matters. And PHP's OO code is slow compared to this style of programming that I do, where I'm using a lot of scalars passing around the place. I believe it came up in the week before the PHP Yorkshire conference, if anyone really wants to scroll back on my Twitter timeline that far. And I actually ran some benchmarks because there was someone saying, make everything objects and all your problems go away. And I actually did an A/B comparison of a real-life system done both ways. And I think it was 4 or 5 times slower. Now, for a lot of you, that overhead's probably not important. I'm dealing with a system that's importing 2 million records at a time. So I've got a lot of tight loops. And unfortunately, CPU time matters for the code I write. So I tend to write the fastest code I can that's safe myself. Yes?
My question is sometimes the problem I find myself when I do stuff like this, when you've got functions maybe calling match token that might have taken the thing, how do you need to sort of put this everywhere in every single function? How do you know where to draw the lines? Because this thing here might be called for something else that took the token in it.
We're going to come back to that. I've got some slides on that. Be interesting to see whether they answer your question. But I do have some slides on that.
That was one of the advantages of putting in a class. Once the class has been validated once, you can pass it on and on and on. So there is some things in there.
Yes, there are. That works if you're using classes, especially if you're using immutability and you're treating them as value classes rather than entities. If you're using them as entities, you've got to make sure, of course, every path into your entity when you're setting data has all the correct validation in place. And my experience with entities, especially in systems that don't use value classes, only use entities, what happens, for everyone else's benefit, a value is something that you set once via you pass all the data that's needed to set it up via the constructor, and it never changes. There's no setters on it. All you can do is get data out of it. You can't change the value or the state it represents afterwards. You have to destroy it and replace it. Anyone who uses PSR7 will have seen that with the way you have to create, when you want to modify a request, HTTP request, you have to constantly create new requests with the modifications attached. An entity is a read-write object. You put data in, you can change that data at any point, you can get the data back out. My own experience with entities is they have a nasty habit of growing. And if they grow too large, you're back into the no one does everything 100% way. There's often a way in. And then you get to the point where people are subclassing your entity, they're inheriting from your entity, adding their own stuff in, and they may not reproduce your validation, and they may go round your validation. They may have subclassed it to get around your validation because they didn't understand why it was there. It may be stopping them. You start to get lots of problems. It can be done. It certainly can be done. Now, outputs. So here's our robust item from before. We've made sure the regex is sane in the technique I'm using. But has anyone noticed that the regex doesn't work? It's a valid regex, but the input data has changed. Beforehand, we were checking for a number. I've switched to hexadecimals rather than just numbers, so base 16. But the regex is still only checking for numbers, so now we have another bug. Because this is not going to produce the right output anymore. It's going to save us no ID because the regex is now broken. So at that point, we're generating an invalid output. So what you can do with this technique is you can check outputs as well as inputs. There's a book that isn't widely talked about. So most people think of, have you heard of Code Complete by Microsoft? Okay, so at the same time, a book came out of Microsoft's Excel team called Writing Solid Code. It's the book in my library, not Code Complete. It's a better book. It's all about robustness. And they've got a whole chapter dedicated just to validating outputs and the importance of it and why. Although it's a book written for C and for Microsoft's conditions in the late 80s, early 90s, it's still a relevant book and well worth recommending to everybody. But we can make sure that we've got something out of the regex, and then instead of return the whole array, we just return the match now. So we're making sure they don't have to check the array's value when it comes back. They're just getting the token out, and they know they're safely going to get it. There is an argument whether this is a correctness check rather than a robustness check. And you could argue it both ways. I argue it's a robustness check because we're stopping a bad value propagating any further in the system. Remember we talked about null perhaps coming from the database by mistake and not being picked up and then being used to calculate sales tax incorrectly. So you want to catch things as soon as you can. Now, objects. An object represents state. It may have one thing inside it, it may have 10 or 100 in, and some of the libraries on the internet, if you dump them, you can't dump them because you get 500,000 lines of state. They can be very complicated, but the thing as a whole is one state at a time as an object. That's the whole point of an object. If objects are simultaneously holding multiple states, there's an argument the code's not solid enough, but that's for another talk. And I've run into this just this very week. Anyone use RabbitMQ? Okay. So I've been plagued by this error when using RabbitMQ from PHP for several days. And if you Google this, you'll find it's a very, very common problem. The error message will change. The delivery tag number will change. Sometimes it's 5, sometimes it's 7. Anyone want to guess what that means? Without going to Stack Overflow. Although actually Stack Overflow is not going to help you anyway, in this case. Yeah, it's not obvious, is it? So what happens with a queuing system is when you finish processing the message, you tell the queuing system, I'm done with this message, you can safely delete it, so that way there's no data loss in case your worker crashes. And due to a bug in my code, I was telling RabbitMQ, I'm done with this message multiple times instead of just once. And they weren't checking for that. So the message itself got into a bad state and resulted in this error. It's obvious, isn't it? Yep. So objects themselves, you have to look inside them. They have to have validators, especially if they're mutable objects, if they're entities, not just values, in order to catch problems. Because otherwise, I have no idea how deep in the RabbitMQ client code this is. I didn't go digging. Life's too short. But it clearly wasn't checking that it was in the right state when I said, free this message. It should have gone, oh, I've already been freed. It knew because I'd called the same bloody thing twice. It wasn't checking that. So the state's important. And it's also an example of how an error that happens, if you don't handle it, you don't catch it, try catch blocks, which we're going to talk more about in a bit, that crashes code, stops your code running. It takes us back to that. That's where we go. So the thing to take away from pattern number 2 is you have a choice, because it's going to happen. Your code's going to crash. Are you going to let it crash, or are you going to put detection robustness in place so it can fail gracefully? Pick one, because one or the other will happen. If you don't put the effort in to make it fail gracefully, it will crash and burn at some point in the future. 3 a.m. in the morning when you're about to go on holiday. That happens. So how do you deal with this? So step 1, we've talked about here, is know that you need to fail. You've got to put these tests in place, however you do it, whether it's via checking inputs as they come in, or whether it's via value objects with their inbuilt invalidator. You've got to know that you need to fail. You've got to put code in there to detect problems, because otherwise you're letting the problem reach PHP. And as we've seen, you can't rely on PHP to tell you there's a problem. And it might be telling you a problem, and it might be putting in a log file you're not looking at, or you may have it switched off. And the second thing you do is fail deliberately. Don't propagate the problem once you've found it. Throw an exception. Throw your hands up in the air and say, hello, we've got a problem. Something's got to change. So pattern number 2 is fail deliberately. And these are the 3 things. You've got to check type and condition. I can't stress that enough. I have done Java. I have worked with Java teams, where obviously Java has always been a strongly typed language. And for many years, I used to have arguments with Java developers because they used to go, we've got types, we don't need to do any unit testing, or we don't need to do robustness testing. Types will save us from everything. The amount of problems we had with that code was a sight to be seen. It wasn't bad code, it was just happy path code. And then robustness happened. So that's pattern number 2. And it gets quicker from here because we're going to start building on these and start building on these concepts. Yes, please.
Can I ask a quick question?
Of course.
Sometimes people wonder about when an exception might be used.
Okay.
And one kind of heuristic is use exceptions for exceptional circumstances.
Right.
So would you say that's right or wrong, bearing in mind what you feel? Or is that helpful or not helpful?
It is helpful. I'd come back to what I said earlier and say, if the happy path can't safely continue, that's when you throw an exception, because you're telling whoever's called you that you cannot continue. Something's happened, you've got to change course, and you've got to do something differently. And if they're not, the nice thing about an exception is they unwind the call stack. So if the code that's called you hasn't got a try-catch block in, that gets unwound, and the thing that called them gets told as an exception. It goes up and up and up until eventually you reach the default exception handler in PHP, if you've installed one. And we'll come on to that towards the end of the talk. I do think don't use exceptions when a null is the right response. So I've seen people use ingrained afraid of null that they'll throw an exception because they don't want to return null, even though null is the right value because there isn't the data. Everything's worked, it just happens there is no data in the database that matches, and null is the right thing. But it depends. I mean, if you're looking up a user ID, you can't have a user ID of null. The user you're trying to authenticate, or the user you're trying to work with if you're validating a PHP session token of some kind, there has to be a matching user. So null there isn't a valid response. You'd have to throw an exception, because you say, look, this user's supposed to exist, and they don't. So you've got to look at that in the context of things. But make it possible so people can write code so it always succeeds. They're not constantly checking return values. I don't know if that answered your question or not.
I was just putting it out there, really.
Fair enough.